Good morning, my name is João Maurício, and today I will present a brief seminar from the seminars course taught by Professor Anderson Coraça, entitled Enteral Methane Emission in the Cattle using the Sulfur Hexafluoride Tracer Method, or SF₆ method. The presentation will begin a brief contextualization of the problem focused on the methane and methanogenesis. Then I will present the SF₆ method, including its story, how sample collection is performed, and how the results are obtained. Starting with the contextualization, methane is the one of the three main greenhouse gases emitted by agricultural and livestock systems. The main characteristic of these gases is their ability to absorb solar radiation reflected by the Earth's surface and re-emit it into the atmosphere, contributing to global warming, which is characterized by the warming of the Earth's surface and the sudden climate changes. Methane is formed into the raw material anaerobic fermentation carried out by methanogenic archaeas. When the feed is ingested by cattle, it's degraded to produce volatile fat acids, mainly acetate, butyrate, and propionate. During this process, hydrogen gas, or H2, is produced and then used by methanogenic archaeas together with the CO2, or carbon dioxide, to synthesize methane. This synthesis is essential for the maintaining ruminal activity because H2 can interrupt the fermentation process. However, the enteric methane produced represents an energy loss for the animal and, when emitted into the atmosphere, contributes to environmental problems. The SF₆ method was initially proposed by Johnson and collaborators in 1994 as an alternative to the respiration chamber method. Respiration chambers are considered the gold standard method for methane emissions analysis, but they have a limitation because they only allow measurements in confined animals. In contrast, the SF₆ method allows methane measurements in grazing animals. To perform methane collection, the following equipment is required: a halter to attach the other devices, evacuated canisters such as the one shown in the image, made from PVC pipe, and a capillary tube with a pressure regulation valve which allows the vacuum inside the canister remain relatively constant throughout the collection period. If we observe carefully, we can conclude that this equipment alone is not capable of collecting all the methane emitted by the animal. Most of the emitted gas escapes into the environment. This is where SF₆ permeation tubes comes in. They are administered by esophageal probe before the beginning of the collection period. These devices are made of brass, filled with, with SF₆ gas, and sealed with a membrane that allows the gas to be released at the constant rate over time. SF₆ is an inert gas, meaning it does not react with the other gas produced in the room. It is not produced by the animal, so our SF₆ detects come from the permeation tubes. In addition, the SF₆ can be easily detected by gas chromatography even at very low concentrations. Thus, SF₆ works as a tracer for the relationship between the amount of gas emitted by the animal, including methane, and the amount collected by the canisters. After the collection, the samples are analyzed by gas chromatography, where the concentration of methane and SF₆ are determined. With this data, it's possible to estimate the total enteric methane emission by multiplying the SF₆ released rate from the permeation tube by the ratio between the methane and SF₆ collected in the canisters, with both gases corrected from the background concentrations in the environment. This is the bibliography used. Thank you.